How can we find the zeros of the function f of x equals x to the fourth minus 4x cubed plus 4x squared? Recall that we set f of x equal to 0 and then we solve for x to find the zeros. So we can write 0 equals x to the fourth minus 4x cubed plus 4x squared. And after factoring out x squared, we get x squared times x squared minus 4x plus 4 in parentheses. We see that x squared is a squared term, 4 is a squared term, and negative 4x is negative 2 times x times 2. So we can write x squared minus 4x plus 4 as x minus 2 in parentheses squared. This is a very good example to show you why I highly recommended memorizing the formula a minus b in parentheses squared equals a squared minus 2ab plus b squared in some of my previous videos. You can also ask the question which numbers multiply to 4 and which same numbers add up to negative 4 to transform x squared minus 4x plus 4 to x minus 2 in parentheses squared. Now, this is 0 when x squared is 0 or when x minus 2 in parentheses squared is 0. X squared equals 0 when x equals 0. But because it's squared, it's x times x. So it actually shows up twice. So what we say is that this has a multiplicity of 2, also called a repeated or doubled zero. When we look at x minus 2 in parentheses squared, the value x equals 2 is what makes this 0, right? Because 2 minus 2 equals 0. We see that this factor also appears twice. The graph of this function looks like this. We see it touches the x-axis at 0 and 2. So when we have a multiplicity of 2, the graph touches the x-axis. In general, we can say that the graph touches the x-axis when the multiplicity is an even number. For higher even powers like 4, 6, 8 and so on, the graph will still bounce off the x-axis. But the graph will appear flatter with each increasing even power as it approaches and leaves the x-axis. However, for odd powers 1, 3, 5 and so on, the graph will pass through the x-axis, but the graph will appear flatter with each increasing odd power as it approaches and leaves the x-axis. More to come, so stay tuned.